Good morning, judges. Myself Mohit from Team Logic Loopers, and our problem statement is AI native job board. So I want to start with a very simple thing. When a company wants to hire someone, what do they usually do? They look at resumes, they take interviews, they may have coding rounds, they see marks, your skills written on papers, etc. But the problem is this does not show how an actual person works and what has he actually done. A resume can be fake or exaggerated. Some people speak very well but they cannot work well. Some people work very well but they get nervous in interviews. And once a person is hired, no one check if the decision was correct. In real life, people are not the same for every task. Some people may be good at type of work but not another. Some may learn fast, then they start working. Some may do very well in certain situations. So hiring is 100%, never 100% sure. There is always some doubt. But current system acts like there is no doubt at all. This is the main problem we are trying to solve. Instead of asking, is this person good or bad, we ask a simpler question. Can this person do this work properly? And if we are not sure, why not give him a small task and check whether they can really solve this problem? So our solution is very simple. We do not depend on resumes. We do not depend on interviews. We look at the real work a person has already done or is actually doing. Small real task instead of big task and the result of that work. Then we slowly understand what a person is actually good at. So instead of matching resumes to job, instead of taking big coding rounds, we learn from the real work and the real results. Now my teammate will explain how our system works step by step.
So myself, Prajar, and I'll be explaining about the solution part. Okay, I mean the technical part plus the solution part. So what we have built is, we are going to build is AI native work allocation engine. Okay, so basically nowadays, like the people are hired based on the resumes or something, but you can yap anything in a resumes. I mean, if you have something like tier one, tier two colleges and all, you can yap anything and you can get a job easily. Okay, but when it comes to tier 3 colleges, even if you have a good skill set and if you don't have that good college or something, then it is difficult for you to compete with tier 1 tier 2. So this is like an issue with resumes, that anyone can yap anything but you don't know the actual skill set that they have. So what we have did is ours is entirely resume free thing. So we don't usually take your resumes or something. We just do some kind of calculations based on what your GitHub has, I mean the particular stack which you have implemented there or something, and I'll go through the solutions anyways there. So this is like AI native work allocation engine, a self-learning system that understands real capability from evidence and outcomes, not resumes, maintains probabilistic beliefs with uncertainty, not static skill scores. Okay, so and replaces interviews with real outcome driven tasks, continuously learns and improves with every task execution. So now we'll move forward and we'll just go with this. Okay, why is this novel? So now novel means, why is this, I mean, why is this not implemented? I mean, how is this different from the traditional hiring and our system? What is the difference in that? In traditional hiring, if you see, there you have ATS or something where you check your resume using keywords, which is actually which is, I mean, if you see properly, resume using keywords, anyone can yap anything in resumes and you can easily do that thing, ATS test and all. But our system is based on real evidence. I'll show you how it works in the upcoming part. And interviews, micro tasks we assign, and skill scores, we have belief distributions for that, and one time decision, we have continuous learning models that I'll show you. Now we'll move forward, that is system overview. Okay, so first I'll explain this one. So what happens in the actual system is, I'll tell you something. See, first candidate comes and candidates uploads his resume or something like GitHub links or something. Okay, if you upload a resume also, we just want that GitHub links and the lead code questions which you have solved, like that we'll take it from there. We'll not scan the resume, nothing we'll do. We just want your GitHub, I mean the sites which you have actually worked on, like that. Okay, and then what happens is, we have GenAI interpretation. What GenAI interpretation does is, we go to your, I mean, using GitHub APIs or something, we go to your particular GitHub account and we fetch the details, like what and all repos you have, the readme files of that repos, and how, what stack you have actually used. I mean, we'll just compare, like the job role which you have and the stack which you have used. We'll just compare both of them. If it matches, then we can suggest as this is the best candidate for this, like that. And we have evidence graph that I'll show you later. Evidence graph is, I mean, it is a core of our entire thing. I mean, it's like a mind of our entire project. And Bayesian belief engines is also there. And uncertainty aware task, I'll take up this later. Task execution, outcome driven learning. Okay, I'll now we'll go one by one what we have actually implementing. Okay, So the next thing is the system architecture diagram. Okay, so now if you see here, so the first thing is candidate inputs. So that one only, GitHub repos, Kaggle notebooks, project blogs, resume or something. Resume is entirely optional. If you just put this much, is okay. And next is and GenAI evidence layer. So what this layer does is, this layer goes to your repo or your Kaggle notebook, projects, whatever blocks you have, right? It just goes there. I mean, we'll integrate APIs for that, either MCP or GitHub APIs like that. We'll integrate for that, and it goes there and it fetches the repo structure. I mean, the tech stack which you have used. I mean, till where your building is done. I mean, how good are you in some particular stacks? We'll just check that one, and then we'll go to something called capability and belief engine. So what this engine does is, see, this is a model. I mean, this I'll show you later. Okay, this I'll show you later. I mean, uncertain avail planner, task allocation, task execution layer is there, and outcome evaluation engine. This I'll show you later. This I'll show you one by one. We'll go one by one easily. Okay, so now next, okay, next I'll show you. Okay, role of GenAI. As I said, it goes to the GitHub repos and all blogs. It just fetches the details of that and generates diagnosis task. It just takes some task and it just gives ki, this guy has made this much contribution to some open source project, which the hiring people want actually. Okay. Mm, Next thing is evidence graph. So this is one of the main, I mean, this is called as the heart of our entire model. Okay, I'll tell you this. What this does is, this is like a knowledge graph. Neo 4G, we are designing that. So what this does is, we have some four nodes. Okay, we have four nodes. It's candidate, skill, task, and outcome. So what it does, candidate is actually connected to skill. Okay, so if candidate has good skill and he can perform good task, then the outcome is good. So this is our knowledge graph. This graph changes each time. I mean, this is like learnable, self-explainable graph. Okay, so I'll just read out from here once. Dynamic knowledge graph that connects candidate skills, task, outcomes in a single explainable intelligent system. It acts as brain of the platform, enabling reasoning, learning, and transparency. Candidate, what he does is, represents an individual work history, and skill is like, what skill is he good at. I mean, we'll have a confidence score. I mean, how he is he good at something. And then we have task, based on the evaluation, I mean, difficulty evaluation, which we will do later. In the later parts, we'll do this task thing. And outcome is like, observe performance, time efficiency, robustness, and feedback, that one. So this graph collects everything which we have. Okay, so whatever candidates will do there, this graph keeps on learning on itself, and this is an entire model itself. Inside that, we have many core components in this, data structures and all we use for this. And in this is a and the next is a capability model. So this capability model has five dimensions, that is competence, reliability, adaptability, learning rate, high context sensitivity. So ability to correct, solve task, and deliver quality outcomes. This is one. Competence is the one, like correct, solve task, and deliver a quality outcomes. Is he the quality candidate for our this perfect job role or something? That we'll check using competence. And reliability is like performance. What is like has he, is he the, I mean, has he ever performed the similar tasks earlier? That we'll check. And in adaptability, we'll check perform under new constraints, like that. Okay, and then learning rate, how good he is in learning or something. Candidate improves with tasks. Context sensitive, how performance varies across environments such as data quality, temperature, or task complexity. Okay, and the next one is belief engine. So what this belief engine does is, so it's like maintains probabilistic beliefs about future tasks. So it's like, I'll tell you something. Imagine if the person is 70% good at something. Okay, 70% good, I mean, if using your GitHub repos, when I fetch that, right, imagine if my LLM says that he's 70% good in some skill like Next.js or something. What we do is, there is a other guy who is 70% better in that also. Like two people are crashing now, so both are 70% better in Next.js. So how will you segregate them? So for this, we have belief engine. So belief engine will tell us what to do with two people. I mean, it will tell us ki, give some specific Next.js task to both, like that. I mean, a particular problem statement will give, so that you can give it to both. We have uncertainty estimation, how confident the system is about each skill, and outcome prediction, like that. That we will check. And confidence intervals represent skill levels as ranges, fixed numbers. I mean, that all are there. And the next one is task allocation logic. As I said, the belief engine will check whether we have to give the task or not. Okay, so this is not a mandatory part. If we think that two or more people are good in some task, we'll give them this task allocation logic. And in this we'll just give them some problem statement. Like imagine if you are good at some NLP or something, then we'll give you something like make something with F1 score 85% more than, I mean, a good model, train a good model like that. Or else if you're good in some nextures, we'll tell him to write some APIs, backend APIs, like that we'll tell. Um, so this was a task allocation logic. I'll just task type a diagnosis rel. I mean, nowadays debugging tasks you need, right? So those are the one. Production tasks, I mean, which real production applications will have. Adaptability tasks like evaluate performance under constraints or environments like that, which is basically ML or something. And next is a continuous learning loop. So now system improves with real world interaction. This is one of the thing which we have considered here. That is, if you know something reinforcement bandits and all, we are using it here so that the loop will get continued. Once this entire flow works, right, now we'll get something, the model, I mean, we'll get the final thing ki this guy was better. So what this guy had will get trained again. I mean, what this guy's skill is will get trained again, so that we can, so that this system can learn much more with this. So like task executed, candidate completes a real outcome driven task. Outcome is measured, I mean, performance is evaluated using quality time and robustness metrics, okay. And casual attribution applied. So can separate candidate's performance for task ambiguity or environmental noise, I'd say. And then is a key insight is a closed learning loop gets smarter with every task. That you have to remember, that this loops get better. So that graph, knowledge graph was there, right, that gets trained continuously, okay. And so next example, I'll give an end-to-end example for now, okay. End-to-end example how this actual whatever I had said, the layers, right. I'll give an entire end-to-end example now. See, the first thing is evidence submission. Candidate submits a GitHub real project, okay, project or repo. Evidence, GenAI analyzes the repo and extracts skills and gaps. So uncertainty detection is system identifies medium confidence in NLP capability, like that. See, so now the thing is there is some detection that he has medium confidence in NLP capability. So he's like 50% good at NLP thing. So now a micro task is assigned. Micro task will be assigned to that person, and now something like generate an project with F1 score more than 85% or something like this. Some NLP task will be given because they are testing for NLP skills here. So now outcome evaluation is like task performance is measured using objective metrics. Yeah. Now, whatever he has coded or something, we'll check that one. We'll check with the actual solution of that, and we'll check what and all brain he has used there, and we'll just make a metrics. I mean, we'll just tell this much he has made proper, like that. We'll send it to the model. So now belief update. So now the belief will the in this one in the I mean the knowledge graph, the belief will get updated. I mean the person is this good. And now production task allocation. Candidate is then real work based on updated belief. So based on the belief score, we are giving him the real work. If the belief score is better, we will be giving him the job assigned or the mini work which the company decides. Okay, based on that, we'll give him the real work, and the outcome of this belief work, we will use it as the new training for the continuous loop. Simple. And now the tech stack I'll explain. The backend is using Python Fast API because of scalable and orchestration layer. And the graph layer, which you said that evidence graph, it is made using Neo4j. Okay, Neo4j. This is a better I mean framework for making graph layers. And machine learning is Bayesian models for belief estimation. I mean Bayesian models are very good when it comes to self learning. Okay, so they are very good at learning. So we are using that. And the next is contextual bandits for uncertainty aware task allocation. So contextual bandits means we are just using RL bandwidths for this one. So that's what it uses, some kind of policy, so that we can train it more and more. And next is generative AI, LLM APIs for evidence interpretation. That okay, we are using some GitHub APIs or MCP or something we'll use. And for infrastructure, Docker cloud deployment, secure, modular, and scalable. Yeah, for this is for deployment thing. So we'll go with impact. For candidates, fair evaluation based on real work, not resumes. So obviously, this is good. I mean, fair. You'll have a very fair evaluation based on the real work, not on the resumes. I mean, we are not even taking any resumes. It's just very optional. Okay, and continuous skill discovery and growth bias from keywords. Yeah, I mean, you know, right, how resumes work. If you have good keywords, then they'll allow you like that. And for employees, lower hiring risk, evidence based checks. Because we are making evidence based decisions, so this is like very better for employees also. And outcome driven task allocation instead of assumptions. That's what I mean. We are not assuming anything. We are just training our model so better that it can provide us better and better results. I mean, it will obviously provide, because the kind of architecture this has, I mean, multi-layered architecture we have here, it will obviously provide a better result, because we are even checking each and every loophole in this. Continuous optimization of workforce performance, optimization is there. And now I'll show the workflow. This is a workflow which I already explained. First, GitHub Gen AI interpretation evidence graph will be there, needs NLP for confidence boost, and a belief engine will be there, uncertainty NPL and NLP skill, what we'll say. And this is the uncertainty planner, and this task allocation, I mean, it is telling build sentiment classifier, and task execution continuous learning loop, that one is there. Okay. And now next one is tech stack. I had explained this one. Gen AI implementation, we are using Python and fast API. Graph database, we are using Neo4j. Evidence graph. Machine learning, for that we are using, for the two models which are shown, there is evidence, that is some I mean, those are two models, right? For that we are using machine learning. And this is Gen AI for LLMs, I mean, Gen AI LLMs and Dockers for deployment. AWS Kubernetes and Docker for, again, infrastructural deployment and all. Yeah, that's it.
So hi everyone, I am Karthik and I am gonna conclude this project. And so to conclude this, this project is about judging people in a better way. So instead of depending only on resumes and interviews, we look at real works, and we give small real tasks and learn from results. This helps us understand what a person can actually do, not how well they can talk in an interview. This idea can also be started as a business. We can start small by working with a few companies, and first we focus on a one type of role like software or data jobs. We give small tasks to candidate and help companies see real performance. This reduces wrong hiring. In the beginning, companies can pay per candidate or per task. Later, big companies can use it as a monthly service or hiring and team planning. So as more people use this system, it learns and becomes more better. So this makes the product more useful over the time. More accuracy means more trust, and more trust means more customers. This system can be used by hiring platforms, freelance websites, and even inside companies to assign work to teams. In simple words, this is a fair system for both people and companies. People get a real chance to show skills, and company make more better decisions with less risk. So this was our pitch, and thank you for listening. Hope you like this. Yeah, thank you.